Logical reasoning is a part of almost all major placement exams conducted in the country and is one of the most scoring sections as well. Placement session is right around the corner, and to make sure that you beat the competition, we here at Great Learning have brought to you this knowledge packed session on logical reasoning. Candidates who are preparing for upcoming competitive exam can find all topics, tips, and some sample questions related to logical reasoning in this course. So without wasting our time any further, let's get started right away. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoy this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.
Now, placement season is round the corner. And to get your dream job, you need to qualify some screening tests that companies conduct, which includes quantitative aptitude, verbal reasoning, and logical reasoning. So, to cater to that, we have come up with this particular course called Logical Reasoning for Placements, in which we will be telling you about the most interesting types of topic that are commonly asked in these exams. Now, these are the screening tests that companies conduct to qualify for their interview rounds, that is the technical interview and their personal interview rounds. So in order to clear those screening tests, there are certain topics that are asked a lot in these exams. So these are number series, linear arrangement, calendars, letter series, cubes and dice reasoning tricks, and also pie charts. So we'll be practicing all these questions on these topics, and also we'll know about certain tips and tricks that help you save time while giving these tests. So this is going to be a knowledge pack session. So make sure you have your notes ready, you have your pen in hand, because everything that we are going to do will be there in one of your placement tests for sure. So without any further ado, let's get started. All right, now let's start with the first module, that is number series. Now this topic would be covered in such a way that we'll have first the most easiest of the numericals, then we'll go on to practice some more tough problems, right? So let's get started with number series. Now number series is something that it is a series in which you have to figure out what would be the next digit that would come up, right? So let's see an example for this. So I'll take an example of 2, 5, 8, 11, 14. And you need to figure out what would be the next number. Now, in order to solve such series, this is the most basic one, but to solve such series, the first thing that should come into mind is whether the series is incremental or decremental. So, which means that if the series is increasing or it is decreasing. So, we can see that 2, 5, 8, 11, 14. The series is increasing. So, next step would be to know what is the difference between the digits. That's usually how we start. So, know what is the difference between the two, right? Consecutive numbers. So 5 minus 2 is 3, 8 minus 5 is also 3, 11 minus 8 is 3, 14 minus 11 is also 3. So now we can see that, okay, all the digits have 3 as a difference between the two, between the consecutive numbers. So now we can figure out that 14 and the next number would also have a difference of 3. So we can add 14 to 3, and what would we get? We would get 17, right? So that is how you know what is the next number in the series. Now there can be another situation. Let's take one more example. Let's take 3, 6, 12, 24. Now let's say what is the next number. Now again, step number 1, we know that this is an incremental series, 3, 6, 12, 24. So next we see what is the difference. 6 minus 3 is 3, 12 minus 6 is 6, 24 minus 12 is 12. Now we can see that, okay, the numbers are not common. So what could be the other way around? We can think in that respect. So we can see, okay, one thing can be, let's say 3 into 1, 3 into 2. This should be 3 into 3, but it is not. This is 3 into 4. So this would not pan out as the table of 3. So we'll think of something else. Isn't it doubling every consecutive number? For example, 3 2s are 6, 6 2s are 12, 3 2s are 6, 6 2s are 12, 12 2s are 24. right? So we can also figure out in this way. Now next number, what would it be? It would be 24 into 2, right? That is how it should be. That is 48, and also the difference between the two should be 24. So this also satisfies. So hence you can figure out what are the numbers in this particular series. We'll take one more example. So let's take the third example: 77, 83, 101, and then we can figure out what is the next number. Okay, so again it is an incremental series. That is our step number one. So we'll see what is the difference between the two. It is 83 minus 77 is 36. 101 minus 83 is 18. So what would be the next number? We need to figure out that. So let's take an example. Okay, let's just consider, let's not consider this. Let's add one more number to it, right? Let's add one more number. Right. So the next number we are considering is 131, and then we need to find out what is the next number. So 131 minus 101, how much it is? It is 30. Okay. So in order to find out what is the next number, we need to look at what is happening. So as we can see that it is 6, 18, 30. Doesn't ring a bell about something. Okay. If it can be a series or something, let's just check it out. I would think in the perspective, okay, let's go about the table 6, right? So 6 into 1 is 6, 6 into 3 is 18, 6 into 5 is 30. Now I can say for sure that, okay, so this is a table of 6 that is going forward, but in what way? It is not consecutively like 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24, because 6 into 2 and 6 into 4 aren't coming in the series. So what would I think? I think that, okay, 6, 1. So 1 is coming, 6 into 3, 3 is coming, 6 into 5, 5 is coming, which means that odd numbers are playing about it. Odd numbers are coming consecutively. So what would I think in the next regard? The next number would be 6 into 7, right? 42. So this would be 42. Now, if I add 131 to 42, what do I get? 173. So this is how I figure out what is the series ahead. Now, this is very, very easy to know once you know, once you are in the habit of doing this. It doesn't require a genius brain to solve these number series. It just that more and more practice would be needed from your end to know these tricks, tips and tricks. All right, so let's take one more example for number series. So the fourth one would be 4, 6, 9, 13, 18, and so again you need to predict what is the number after 18. In order to do that, again you will see first, is it a incremental series or a decremental series? So as we can see, it is increasing, hence it is an incremental series. Now we'll take the now step 2, we'll subtract the digits. So let's see, 6 minus 4 is 2, 9 minus 6 is 3, 13 minus 9 is 4, 18 minus 13 is 5. Now, as you can see that we can actually see it. So 4 and 6 is 2, 3, 4, 5. Now, for the matter of fact, we know that, okay, this particular number is increasing. The difference between the two consecutive digits, they are increasing by plus one number, right? So 2, 3, 4. Now we know that next number would be an addition of 6 to the previous number. Now it would be 24. So this is how you could know that what would be the next number. We'll take one more example for the same. So that would be 10, 31, 95, 288, and 868. You need to find out what is the next number. Now, in order to do this kind of number, you need to again see if it is an incremental series. Yes, it is. Number two, you need to see that whether the difference between the two does make sense of any kind, make any pattern of any kind. So we need to look at that. So let's take that. The difference between is 21. 95 minus 31 is 64. Then 288 minus 95 is 193, and so on. So I'll just quickly check if there is any pattern in the first three one. So 21, 37, 64, 193. So it does not really make sense having a pattern of the difference. So we'll use another method. We'll think about another way in which we can do. So if this is 10, right? If this is 10, now I'll see if I can multiply something to make the second digit, right? So if I have to multiply, if I have to get 31 by using 10, how would I get? 3 into 10, 30 plus 1, 31, right? Now let's see in this case, is it true? 3 into 31, 3 is 93 plus 2 is 95, right? And then let's take 3 into 95 plus 3. This is how it should be. Let's check if it is satisfying it. 385, 388. Yes, it is satisfying. 288. So we can know, for the matter of fact, the thing that we got out of this is that this this series follow this particular expression, 3 into the previous number n minus 1 plus the digit, so it can be n. So this is following something of this scenario. So let's just take this example. What would be the next number? It would be 3 into 868. This was 3, right? 3, this would be 4, this would be 5. Now let's take an example. 2604269. This would be the answer to the particular problem. Now, if I have to take another example that is little different and little hard in terms of placement perspective. Okay, again, these questions are not for any entrance exam basis. So this particular questions that we are trying to practice is particularly for the screening test for the placements, right? The companies come, they give their screening tests. This is purely based on that. They do not want you to know everything about these logical reasoning. They just want to know that whether you know the concept or not, right? So you just need to practice some basic sums and you will be good to go. So this one is little hard, so just pay a little more attention on this one. So 43, 50, 55, 65, 76 and 89, right? So you need to figure out what is the next number, or did you I'll just give you the answer only. You need to figure out how you got 89. So how can we solve this, right? How can we solve? What is the pattern behind it? If we see first, is it an incremental series? Yes, it is an incremental series. Then we will see what is the difference between the two digits. 50 minus 43 is 7. 55 minus 50 is 5. 65 minus 55 is 10. Then 76 is 11. And then it is 13, right? We got this. So if we see closely, we do not know that if there is any pattern involved. Number one, because the difference in itself is decreasing and increasing. You can see 7, then 5, then 10, then 13, then 11, then 13. So we see that there's not a regular pattern that is being followed in this particular sum. Then what would we do? We would use our brain. We'll think in a little more different perspective. Now let's see this. 43. 4 plus 3 is how much? 7. 50. 5 plus 5 plus 0 is what? 5. 55. 5 plus 5 is 10. 65 is 11. 7 plus 6 is 13. Right? So now we could know that, okay, the difference, the next number is the sum of individual digits of that particular number. So for example, 43. 4 plus 3 is 7. If I add 7 to 43, I get 50. 50, the sum is 5 plus 0, individual digits. 5 plus 0 is 5. If I add 5 to 50, I get 55. 55, it is 5 plus 5, 10. If I add 10 to 55, I get 65. 65 is 6 plus 5 is 11. If I'll add 11 to 65, I'll get 76. 7 plus 6 is 13. If I add 13 to 76, I'll get 89. So this is how you formulate. This is on the little more tough side because at the beginning we don't actually think about adding the particular digits, since we have a time crunch as well when we are solving the papers. So the step number one would always be to see if it is an incremental or decremental series. If it is an incremental series, we think about adding something, multiplying something. If it is about decremental series, we try to subtract something. So this is how number series plays out in the placement test. It is very fairly easy when it comes in the placement test, but you need to make sure you practice a lot on this topic. So the next important concept is linear arrangement. It tells us about how, direction sense, how the seating arrangement is when someone is sitting on a round table or they're sitting on a rectangular table, or if a person is sitting side by side. So it's just about logic, how well you can think, how well you can imagine the places people are sitting. So let's get started with this particular section called linear arrangement. So before knowing linear arrangement, we need to know specific things. For example, the clockwise would always be clockwise irrespective of wherever you are sitting. It does not depend on your position. Clockwise will always remain clockwise. Anti-clockwise will always remain anti-clockwise, right? Next important thing is that the directions, right? Top is north, bottom is south, then it is west, east, right? This is important. The lines, this is northeast, southeast, southwest, northwest, right? This changes according to the person. This universally does not change. Left and right according to this position will change, right? I'll tell you, if a person is standing here and he's facing north, right? Now if I say left, which it means here, L. If I say right, it will be on this side, right? But if the person is facing south, right, then I say the right of that person. So the right would not be this, right? The right would be this. The left of that person, for left for that person would be the right of how we are seeing it right now. So this is the thing that we need to take care. Left and right changes according to the place where the person is sitting, right? This is an important concept to know, right? And also, let's get started with the first question. A man walks 4 kilometers south, right? So I'll just read out the question first. A man walks 4 kilometers towards south and then turns to his right, to the right. After walking 2 kilometers, he turned to left and walks 4 kilometers. Now, in which direction is he from its starting place? This is very important. From its starting place, you have to tell. Okay. So I'll start with the first line. The man walks 4 kilometers towards south. So 4 kilometers, the man walks towards south. Then he turns towards right, right? Turns to the right. Now his right would be this. He turns right. Then he walks how much? 2 kilometers. Then again he turns to his left. Now he's standing over here facing this side. His left is towards the south, right? He turns to the left and walks 4 kilometers again. Now, at what position is he from his starting place? Now, you don't have to tell at what position he's standing. He's standing here towards south, but you have to tell in accordance to the starting position. This is the starting position. Now, according to this, he is standing north, south, east, west. He's standing in southwest direction. So the answer to this question is southwest. All right. Next question. A is 40 meters southwest of B. Okay. Southwest of B. We'll again make north, south, east, west, and he's southwest, right? So A is 40 meters southwest to B. C is 40 meters southwest to southeast to B. Okay, C is southeast. This is southeast to C. Now, then C is in which direction of A, right? C is in which direction of A? C is in the east of A, right? This is east. So the answer to the problem is that C is standing to the east of A. All right. Now let's talk about the linear arrangement, right? We were talking about sitting plan, how a person is sitting in a circular table, of they're sitting in a single row, how the changes are there. So this is a problem statement. We will solve the questions pertaining to it. Next, we'll know about the linear arrangement that we are talking about, like if people are sitting in a particular table, a circular table, or a rectangular table, or a single row, how they are facing each other if they are on a round table, or if they are sitting in a single row, where they are facing, who is right next to him, next to them. So all that. So in this particular section, right, a problem statement will be given to you. That problem statement would have number of statements in which you have to figure out where everyone is sitting. Then you would have a bunch of questions that you need to solve, right? Just in this case, we'll try solving these three questions, but first we'll know where everyone is sitting. So let's read the question and get started with it. So P, Q, R, S, X, Y, Z are seven friends. Okay, they are seven friends sitting in a single row facing north. Okay, so the first inference is that they are sitting in single row and they are facing north, right? So what I would do, I would make seven columns for them. 1, 2, 3, 4, 5, 6, 7. Okay, single row facing north. So everyone is facing towards the north, which means that this is everyone's left is this, and everyone's right is this, right? This is the first inference from the first statement. Then comes S is to the immediate right of R, right? S is to the immediate right of R. Since we do not know anything, we cannot come to this. So we'll move on to the next statement. X and P are the neighbors of Y, which means that, okay, X and P are the neighbors of Y. So it can be either this or P, Y, X, this. Okay, two can be made, but we cannot fill in where everyone is right now. Then let's come to the next statement. Q is to the immediate left of R. Okay, Q is immediate left of R and on the second place from the leftmost end. Okay, this is the leftmost end, and Q is to the immediate left of R, and it is, so this is Q because it is from this leftmost end, second place from the leftmost end. So Q is here. Now Q is immediate left of R. It means R is here because Q is to the immediate left of R. So we got one statement is cleared. Now P is at the rightmost end. Okay, this is the rightmost end. Okay, P is sitting here, right? So this is also solved. Now if we go to the second statement, that X and P are the neighbors of Y. Now if X and P are the neighbors of Y and P is at the rightmost end, right? Last statement, which means that P cannot be in the middle, so it has to be at the end. So we will go with the next two things, X and Y. Now we know for sure that Y would be here and X would be here, right? Now we are left with two empty columns. Now let's read the first statement. S is to the immediate right of R, right? S is to the immediate right of R. This is right. So S is to the immediate right of R. Now we can know what is left. Z is left, so we can place it over here. Now our sequence is complete, right? This is the first step. Our sequence is complete. Now the point to be noted in this is that the first statement, you don't have to stick with that. If it does not make sense, move on to the next statement and try knowing what is happening from the next statement. Don't stick to one statement and then rub your head that okay, it's not coming out. It will not come out because it is structured. They want the placement screening test. They want you to know what is happening. So you want to read the entire problem statement before thinking too much about what is happening. So if you're stuck in one statement, move on to the next statement and try thinking from another perspective. That is how linear arrangements are done. Now we have this sequence ready, right? Which is Z, Q, R, Z, Q, R, S, X, Y, P, X, Y, P. Now, since we have made this arrangement, now we can answer the questions. Who is in between R and X, right? R and X, who is in between R and X? The answer is S, right? Now we can answer these questions very quickly. Who are the neighbors of Z? Okay, though there is only one neighbor of z, that is q, so we will write the answer is q. What is the position of x? X is third most from the right? This is the position of x, or we can say fifth from left or third from right. So this is all the answers to the arrangement. This is how the arrangements are done. It's very easy. You need to simplify the problem statement. That is a must when you talk about linear arrangements. So the next module that we will be talking about, we'll be practicing, is called calendars. Now, calendars is widely asked in placement papers. So let's look at what it is. So what happens in calendar is that we need to first understand the concept behind it, because without understanding the concept, you cannot solve the problem because it is too complicated to solve. So let's first try to understand what the concept says. So as we all know, that 1 week consists of how many days? 7 days, right? So if I say that today is, let's say, Wednesday, right? So if I add a week to it, 1 week, which is equivalent to 7 days, what would be the day? If I add 7 days to Wednesday, what would be the day? The day would again be Wednesday, right? Because a week has 7 days. Similarly, if I add this Wednesday with 8 days, what would be the day? The day would be Thursday, right? So now when I try to make you understand this concept, you would know that 8 days is equivalent to adding one extra day, right? So in this particular section, we'll know about such things. So let me try to understand. Now the concept of this particular one day is called the odd days, right? Odd days. Now how it is calculated? It is calculated as the number of days, right, divided by 7 because it's a week, and what would be the remainder would be your odd days. Odd days. Now let's take an example. If I tell you today is Tuesday, and if I add, let's say, 50 days to it, what would be the next day, right? This is the question that I'm asking you. So how would you calculate? As mentioned in the formula above, you would first divide 40 with 7, that is, which leaves the remainder 1. So which means that adding 50 days is equivalent to adding 1 day. So the answer to this particular problem would be, if you add 1 day to Tuesday, what would be the result be? It would be Wednesday. So this is how you solve a problem in calendars, right? Now let's take another example, another concept, that is about leap years. Now leap years are also a very significant factor in considering. Okay, one more thing that I would like to draw your attention is that if it is Wednesday, let's say Wednesday, if you add the multiples of 7, right? If you add multiples of 7, the remaining day would be the actual day itself, right? Because it is multiples of 7 that we are talking about. So the remainder of multiples of 7 would always be 1. So you would always act plus 1 days to it, right? Right. So we were on the topic of leap year. So one leap year consists of how many days? 366 days. One non-leap year consists of 365 days. As we all know that Feb has 29 days in a leap year, and in the normal non-leap year it is 28 days. So a question would arise that how would we know that if a particular year is given to you, how would you know if it is a leap year or not, right? There's a concept behind it. Let's know that. So if the year that is given to you is a multiple of 100, is a of 100, right? If it is in the form of, let's say, 100n, then you need to check the divisibility of that year with 400. All right. So basically it should be a multiple of 400n. So let's just take an example of it. If I consider 2100, right? If I divide it by 400, it is not completely divisible, right? So hence 2100 is not a leap year. Let's take another example. Let's say 2000, year 2000, right? So first is, it is a multiple of 100. Yes, it is a multiple of 100. Is it divisible by 400? Yes, it is divisible by 400. Hence, it is a leap year. So the year 2000 is a leap year, right? This is one more concept. Now, if I take one more example of this, let's say if the second case, if the year is not a multiple of 100, right? If it's not a multiple of 100, then how would you calculate? Then you need to check if it is divisible. You have to divide it by 4, right? You need to divide it by 4, and you need to know that if it is divisible by 4. Now, how do you know? Divisibility of 4 is checked by the last 2 digits. So if I give you a random year, let's say 2016, right? So you need to divide this particular year. Now this does not contain, it's not a multiple of 100, so it comes under this B category, right? And so hence we'll check its divisibility by 4. So if you divide, last 2 digits is a multiple. 4 4 is 16 is a multiple of 4. Hence this is a year. And we can take any other example, 2000, let's say 13. If you divide this by 4, it won't be divisible. Hence this is not a leap year. So this is how you can calculate if a particular year is a leap year or not. All right. Now, if I tell you about one more concept, it is not purely a concept, but purely a thinking basis. So if it is a leap year, right? If a particular year is a leap year, then if I say today is Wednesday of, let's say, 20th March, right? Of X year. Now, if I consider the same date next year, let's say 20th March of next year, XX plus 1 year, then what would be the particular day, right? This is a question. Will it be Thursday? Will it be Friday? What would be the day, right? So in this particular case, if it is a leap year, then the difference between today and the next year of the same day will be of 2 days plus 2 days, right? In a leap year. If it is not a leap year, if it is just a year, then the difference between them will be 1 day. Now let me try and make you understand this particular concept. So let's say that today is 1st Feb of 2017, let's say. Now I want to know what would be the date of 1st Feb 2018. What would be the day? Now, if I consider this day to be, let's say, Monday, what would be the day in on 1st Feb 2018? So for a matter of fact, I would first check 2017. Now, this comes under the second case that we studied, that it is not a multiple of 100. So we will divide this particular number with 4, which is not divisible. Hence, 2017 is not a leap year. Not a leap year. Hence, the particular day, right, 1st Feb to the next day of 2018, the difference between the two would be of only 1 day. So I can say that for sure that 1st Feb 2018 would be Tuesday, right? Similar to this, if I consider first, let's say 1st or 21st Jan 20, let's say 2012. And if I say 21st Jan of 2013, what would be the day? If I consider this to be, let's say, Friday, what would be the day on 21st Jan 2013? Now, 2012, we'll check for 2012. 2012 falls into category B, hence, because it is not a multiple of hundreds, hence we will check it by divisibility by 4. last two digits are divisible by 4, hence 2012 is a leap year. So since it is a leap year, the next year, right, the next year, what would it be? It would be the addition of 2 more days to it. So if it was Friday, adding 2 more days, then 21st Jan 2013 would be Sunday, right? This is how you know about what day comes when, if it is a leap year or if it is not a leap year. Now, these are the basic questions that come in the placement exams. Mind you, this is not a CAT exam. This is not an exam for an entrance test to a MBA college or higher level examinations. This is for placement purpose, and placement exams are purely for screening. They just want to know that you have the basic knowledge of how this is done. Hence, we are doing the most basic types of problems so that you could clear your placement exams. All right. Next, let's talk about what is the letter series that we are going to work on. So, letter series would consist a lot of different things, but first it consists of set pattern of alphabets. So, the first step what we would do in analyzing the letter series is to know the alphabetical order. You should know the alphabets in order. That is a must to know. So, let's take a quick example of our first numerical in this regard. SCD TEF UGH VIJ, and you need to find out what is the next set of alphabets that would come after VIJ. So what is the basis of finding out this is that you need to carefully analyze and compare the two set of alphabets. So you would compare this with this set of alphabet and this with this set of alphabet, right? So this is how you would consider knowing it. So in this particular thing, I need to first see at individual alphabet. So I see S here, I see T here, I see U here, I see V here, right? Now I'll quickly write down the alphabetical order: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Now, if you consider me, if I'm sitting for placements, if I'm giving the test, right? So what I would do is that on a sheet of paper, I'll quickly first write this so that half of the work in solving the letter series becomes easy. Now see, S, T, U, and V, right? Now S, T, U, and V, they are in order. So S, T, U, and V, they are in order. Now I can certainly say that the next series, the next set of alphabets would have their first alphabet as W. This I can say for sure because S, T, U, V, W, that is what is coming, right? Now I'll see what is there any pattern in the next digit, the second alphabet. Does it have any significance? So C is here, and in this second set of alphabets, E is there. Third, it is G, right? So it is happening that you have a alphabet missing in between. You have C, you have E, you have G, you have I, right? But if you see the next alphabet, the third alphabet, that is D, F, G, and J, which equally fills what was remaining, right? Which means that the last two alphabets, right, they are in order, right? C, D, E, F, G, H, I, J. Now we know what will come next. K, L, right? J is done. K and L will come, right? So hence we know that the next digit, the next set of letters would be W, K, and L, right? This is how you solve it. Now let's take one more example. Now this time let's take an example: C, M, M, E, O, O, G, Q, Q, I, S, S, and then you need to find out what is the next alphabet that is coming forward. Now, considering the same pattern what we did earlier, we'll first see what is the first alphabet says: C, E, G, and I. We'll go to the series C, E, G, I. I can surely say that it is skipping one letter in between, and then going ahead. So I can say, okay, the next digit will be K, right? So I'll write K here first. Now I'll analyze what are the remaining two. MM, OO, QQ, SS, right? Now I'll go back. MM, OO, QQ, SS. I can surely say that you have to skip one letter and you will have U, right? So the next two digits, it is static, right? The last two digits, the last two alphabets are static. So you will have KUU, right? So simply we could solve it very easily. This is very easy to solve. Then comes another, let's take another example, B2, little different one, B2CD, BC3D, BCD4, then there is a gap, then BC6D. Now you can analyze it. B is 2 here, then it becomes 1, then it stays 1. So it does not make a good sense of what the series is. Then we'll see C. C is here, then C becomes 3, then again C doesn't really make sense. Even D doesn't really make sense. But if you see the numbers, right, it is coming on B as 2, then 2 gets incremented by 1 to C, C3. Then C gets incremented 1 to D, D4. Now there's a gap in between, but if we see what is the next one, it is B, C6. 5 is remaining. Now, if these three are in order, 2, 3, 4, it will again go back to B, right? So the next digit will be B5, C will remain constant and D will remain constant, right? So the missing series would be B5CD, right? This is how you know it. Okay, let's take one more example. So let's take one more series. So ELFA, GLMA, ILJA, KLLA, and then you need to find out what is the next series that we'll be looking at. So again, you need to see the same way we saw E. We need to write the alphabets in order: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So again, E and G. Where is E? Okay, E, G, I, K. Again, there is a one letter in between that is missing. So we can say for sure that after K we'll have L missing and then we'll have M. So the first letter we'll just write M. Now we'll see L, right? L here remains L, remains L, remains L, remains L. So L will remain the same L. Then again comes F, M, J, L. Now let's see F. Where is F? F, M. Okay, M, J, J, L, L, right? So does this make any sense? Just look at it. F, A, okay, let's leave the third one first. Let's see the last one. A remains the same, A remains the same, A remains the same, A remains the same. So we'll have A mentioned over here. Then how would you say what would be the next letter? Now just carefully analyze it, carefully see what is happening, right? You had F here, F here. Then you had M here, you had M here. Then you had J here, you had J here. Then what would you have? Now, if I consider F and the third letter J, how much is the gap between? 1, 2, 3, 3 letters, right? Now, what would be the difference when we talk about M and after M, J, we went back how many? 2 digits, right? Now J, we will again move ahead after J to the third one. We'll move ahead by 3 letters. What would be K, L, and M? We would be, so the remaining would be N. So the missing value is N. Our series is M, L, N, and A, right? It is all about practicing. It's all about figuring out what is happening. Either you can see the connection between these two, you can see the connection as in this case between the missing 1 and 3, you can see between 2 and 4. So you need to constantly look around which one is the best suited one that comes along in the sequence. But make sure the most important aspect is to note down the alphabets, right? Note down the alphabets. That's the utmost importance when it comes to letter series and knowing what is happening in letter series, right? It is very easy. They won't ask you tough questions. But again, during these papers, right, you have very little amount of time with you. So you need to make sure that you are giving enough time to logical reasoning, quantitative aptitude. So doing quickly, these questions are a must. So just note down this series and just get on with the questions. That's how you solve letter series. All right, let's talk about the next topic, that is the reasoning skills on cube and dice. Dice is the one that we play in Ludo, right? Ludo and also cubes, right? There's certain sections that like how many cuts can be made to get the maximum amount of positions of the cube and everything. So these are the things that are if a side is painted. So questions related to that dice is rolled three times. Find what would be opposite to something. So these are the types of questions that you get in cubes and dice reasoning tricks. Let's get started by knowing first the concept, first the basics that you must have learned in your ninth class, in your 10th class, but we'll quickly recap what it is. So if I consider a cube, right, a cube, I'll make the cube as well. So how many sides does a cube have? Or let's say faces. How many faces does a cube have? The cube has six faces, right? One, two, three, four, one top and bottom. So six faces. How many edges does a cube have? How many edges does a cube have? Just look at it. How many edges does a cube have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the number of edges are 12. How many corners are there in the cube? Corners. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8 corners in a cube. So these are the three most important things that you need to already know. Then comes, what is this side called? This is called length, this is called breadth, this is called height, right? What is the volume of a cube? Volume of a cube is how much? It's, and in cube, L equal to B equal to H equal to A. So the volume of the cube will be a cube, right? Then what is the total surface area of the cube? It is the number of sides into a square, which is 6a square, right? So these are the things that you need to know before starting with cube. So to give you a quick recap of of dice, how dice works. So if you roll a dice thrice, right, this is the most common type of questions that you get. The dice is rolled three times, and find what is opposite to two dots. Okay, you can see these are the dots, right? So it is basically asking, if this is the side which has two dots, what would be the side that is opposite to it, right? So how do you solve these questions? You see the pattern between all the remaining two dice, right? So if you have two here and you need to find what is opposite to two, you would carefully look what is opposite, what are in the next two dice, right? You leave that dice for some time, then you'll carefully analyze the second and the third dice. So in the second dice, we can see that five, where the five dots are there, it is adjacent to one dot, and it is also adjacent to six dots, right? This is the first inference we get. Then on the third dot, we have 5 here. This is 5. 5 is adjacent to 3 and 4. So 5 is again adjacent to 3 and 4, which means that 5 is adjacent to 1, 6, 3, and 4, right? And you could ask, why did I choose 5 here? Why I specifically chose 5 to C, right? Because it is common in both first and both second and the third dice, right? 5 is common, so that's why I took. Since 5 is adjacent to the four numbers 1, 6, 3, and 4, and there is only one number that is left, that is 2. Hence we can say that 5 is opposite to 2, right? This is the first answer we get, right? All right. So next question. Okay. This is also the same thing. The dice is rolled thrice. Instead of dots, we have numbers here. So again, we need to find, let's say, what is opposite of we can take any number. Let's say, what is opposite of A? Let's say that. Okay. Now let's carefully analyze what's happening between in these two dice, right? A is here, so we'll leave A here. What is the most common thing that we see in these two dice is B, E, right? So we'll analyze E. So in the second dice, E is adjacent to D and C. In the third dice, E is adjacent to F and B, right? So since E again is adjacent to what? D, C, F and B, and there is only one thing remaining, that is A, hence we can say that E is opposite to A, right? So solved. So this is how you solve these questions. This is pretty easy ones we get. There's not much thing to do in these questions, but they are more important to know when it comes. All right, in this particular model, let's talk about data interpretation and pie charts in particular, because these are the most important aspects that come in the placement exam. So in placement exams, there is no separate sections for data interpretation. It comes under logical reasoning on some aspects. So we'll try to understand pie charts and numericals, and also some tips and tricks that you need to know while solving questions on pie charts. So the first thing that comes to our mind is pie charts functions with two things. One is the angle, and the second is percentage. So these are the two important things that you need to know while solving pie charts. So if I consider pie chart is a circular, right? It's circular. So I need to know what is the total angle of a circle. That is what? At any point, the total angle would be 360 degrees, right? Now these 360 degree would constitute in numerical terms in as 100%, right? This is the relationship between angle and percentage. 360 degree would be 100%. Now, in order to know that, what are the different aspects we can do is 10% would be equal to how much? It would be equal to 36 degrees, right? 1% would be equal to 3.6 degrees. 25%, that is one fourth of the pie chart. One fourth of the pie chart would be how much? It would be 360 divided by 4, that is 90 degrees. Similarly, what else? 50%. 50% is how much? 180 degree, right? So these things you should know in hand. Definitely you can calculate it, but this should be on your fingertips every time you solve questions on pie chart. Now let's take a brief example of how pie charts are. So if I'll just give you a brief example. So if a business owner earns around 1 lakh rupees. Okay, earns around 1 lakh rupees. Now he spends 25,000 rupees as raw materials, and he spends, let's say, 50,000 rupees. Okay, 50,000 rupees are its profits. Okay, then 25,000 he spends on his bills, electricity bills and so on, right? If I have to display these numbers on a pie chart, how would I do it, right? I'll create a circle. Now I would see what it is. So 25%, 25,000 of 1 lakh is how much? It is one fourth, which means it is 25%. And we know in the previous slide that 25% is 90 degree. So I will make a 90 degree pie chart for this is raw materials. Now the second is his profits. He's having 50,000 as profits, right? So this 1 lakh was revenue, which includes his costs and all the expenses. So 50,000 he's earning as profit. 50,000 of 1 lakh, right? How much it is? 1 by 2. 1 by 2, that is 50%. And 50%, as we know, is 180 degree. Is 180 degree, right? This is his profits. He's earning half of the profits. Then comes he's paying his bills. How much would that be? That is the leftover amount. And also you can calculate 25,000 again of 1 lakh is how much? One fourth, 90 degrees. So 90 degrees is his bills. So this is how you would know how a pie chart looks when you're given complete data. A data set is given, you can convert into a pie chart and vice versa. Right? Now let's take a question. So there is a book company, a company that manufactures a publishing house. So let's take an example of what are their costs. So if I consider the costs, right? So 30%, 30%, 30% is the printing cost. Next 20% is the transportation cost. Another 15% is, I'll just mark it 20 here. Another 15% is the cost of paper. Cost of paper. Then comes next 10% is binding costs, right? Bind the book together, so that is 10%. Then comes the royalties on that books is 20%. And last is the cost, marketing cost that is 5%, right? So 30, 40, 50, 60, 70, 80, 95, 100. Yeah. So 100% is complete. So this is the data set this is the pie chart that is given to you in terms of percentages. Now you need to solve certain questions regarding it, right? You can take a screenshot of this particular question, then we'll move on to the specific question of this pie chart. So the first is, if for a certain quantity of books the publisher has to pay 60,000 rupees, okay, 60,000 rupees as printing cost, then what would be the amount of royalty that needs to be paid for these books? So basically what is asked is that you need to calculate how much is the royalty paid for these books when the printing cost is 60,000 rupees that is mentioned to you. Now, if you go back to the pie chart, you need to first know what are the percentages of these both the things that have been asked. So printing cost is 30% and royalty is 20%. So I'll just mention it there that printing cost is 30% and the royalty is 20%. Now, this is a very basic scenario that you would just use a ratio and proportion to solve this. How? If the printing cost, let's say 30%, right? 30% is 60,000 rupees because that is mentioned in the exam in the problem. And you need to calculate, if I take the ratio of the royalty that is 20%, and I need to calculate what is the actual cost of, or what is the amount that is paid for this books in royalty. You need to calculate that. If I take just a simple ratio, I'll get it, right? Because it should be proportional. It's in pie chart, so it should be proportional, right? So if I consider this, right? If I consider this 20, if I take this back here, 20 divided by 30 would be equal to R divided by 60,000, right? Which further simplified will be 60,000 into 20 divided by 30. 3 to the 6, 4, right? This would be the royalties paid for it. So this was the first. Very easy questions. You just need to analyze the pie chart and solve it. There's no much brain to use in this. It's just simple maths, right? So the second part is, what is the central angle of the sector corresponding to the expenditure incurred on binding? Okay, now let's just go back to our data set. Just go back to the pie chart. Binding constitutes of 10%. It's just asking what is the angle that will be formed in the pie chart for binding. That's what it is asked. What is the central angle of the sector corresponding to the expenditure on binding? 10% is the expenditure on binding. So the entire pie chart is of 360 degrees, right? So 10% of 360 degree, 10% of 360 degrees. That is 36 degree will be your central angle. angle that will be made on this particular pie chart, right? That is 36 degree. And we can also know that since we solved it, right? We already mentioned in for a quick note that 10% is 36 degree. Okay, this is note very important. You need to learn it, and this is how you solve questions on pie charts. Now let's look at what we have learned so far. We discussed some tricks to solve the questions in number series. Then we moved on to understanding the linear arrangement and also the direction sense, right? We knew about what is happening with when people are sitting in a round table, a rectangular table, in a linear single row arrangement. We solved the numerical on that as well. Then we moved on furthermore, we learned about the calendar tricks and letter series. Now these are the most important types of things that are commonly asked in the placement test. So calendar tricks, knowing about the dates, the days, and also the letter series. What is the thing that is required to be known when you come across letter series? And finally, we discussed about the dice questions, that what type of number comes, how are they arranged, what number is adjacent to what number, and also knowing about the data interpretation in pie chart. Now, data interpretation takes a very important role. It is commonly asked in almost every single screening test, right? Data interpretation using pie chart. So we learned about that, we practiced that also. So I hope you had a great learning session with this course. For more such videos, stay tuned to Great Learning.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell so that you don't miss out on any new update or video releases from Great Learning. If you enjoyed this video, show us some love and like this video. Knowledge increases by sharing, so make sure you share this video with your friends and colleagues. Make sure to comment on the video for any query or suggestions, and I will respond to your comments.